Hey, welcome everybody. We're gonna go ahead and kick off here in just a few more seconds. Just waiting for everybody else to get a little bit of time to join the webinar here. Nice. It's like participants is skyrocketing here. Cool. Hopefully everybody is enjoying the day so far. Hello, hello. Awesome. 61 folks in the chat, in the session. Awesome. All right, so for this session here, if you have any questions, there's a Zoom chat and a Zoom Q&A. Feel free to drop anything in there. Let's see. How long is this webcast? This will be 2 hours. All right, we have a few labs that we can put you all through. Cool. All right. Looks like we got 64 folks in here, so that's pretty close to what we expected to jump in for this. So without any more delay, let's go ahead and officially kick this off with some introductions. All right, so my name is Jonathan Ryder. I'm the author of Security 670, and that is basically a course focusing on creating Windows implants, going back down to the roots of programming using C and C++ as well. We mix and match throughout the week. And what I wanted to do was I wanted to create this, hopefully a 5-part series of workshops to basically serve as a prerequisite for Security 670. I've had a number of folks ask me, hey, Jonathan, I don't know anything about C. Should I go ahead and sign up for your course? And I say, no, I would hold off on signing up for 670 if you don't know anything at all about the C programming language. All right. So some folks have also asked me, hey, where is Security 570? Right? Maybe we should have 570 before 670. I'd say, maybe, maybe not. So instead of making another course to do an introduction to C, comma, for Windows, I decided to go ahead and pull in Jason, and we'll do like a 5-part series. Hopefully, depending on everybody's schedule, if we can do this, basically one workshop for the next 5 months. All right, so we'll be looking at a date for something in July, probably towards the end of July. End of July will be part 2 of this series. All right, and for those who have registered and stuff, this is all going to be recorded, so you can dip out at any point in time if you would like, and you'll be able to watch the recording in its entirety at some point after the fact. And also, you should be able to share this with others. Registration will be opened again after the recording has been uploaded to SANS. So that'll be pretty cool. All right, so a little bit of background about myself. I've been in the Air Force for over 19 years now, and good old 20 is coming up real quick, and we'll see how much longer I stay in past that. For the technical side of the house, I'm a developer in the Maryland Air National Guard with U.S. Cyber Command, doing some fun things there. And that's pretty much it in a nutshell. And then my panelist or my co-host with me for part 1 and hopefully for all 5 parts of this workshop series is Jason. So Jason, if you could give a quick intro about yourself, please.
Absolutely. So I'm a developer like Jonathan in the Maryland, Virginia, DC region, Windows primarily, and I'm a real enthusiast of C and begrudgingly of Python. And I'm here with Jonathan as an instructor in development for 670, and very excited to work with SANS for lots of development-oriented coursework and broadcasts such as this one.
Awesome. Thank you, Jason. So I see a couple questions of, can we use Visual Studio 2022 instead of 2019? The answer is yes. We're not going to be diving too deeply into the finer nuances, if you will, between 2019 and 2022. So you really shouldn't see any kind of differences between those two versions, other than the sheer size of 2022 and the system requirements that 2022 needs to run at optimal performance. All right, so if you were ever to do a little comparison of 2019 and 2022, the specs for your system, you'll notice a huge jump for, I think, RAM for 2022. All right, so now we have introductions and stuff out of the way with. I do want to talk about the agenda for this particular series and also for the entire series. All right, and while we're chatting away here, if you haven't downloaded Visual Studio, either 2019 or 2022, doesn't matter, go ahead and get that done now while I'm blabbing away here. So for this first part series, I want to introduce you to Visual Studio. Some folks who have never done C programming, this is going to be specific for Windows. All right, so I'm going to be using the native or the Windows preferred version for development for Windows platforms, programs, desktop GUIs, whatever you want to call it, using Visual Studio. All right, Visual Studio has some pretty awesome capabilities, as we'll get to here shortly. And then for this first part series, walk you through how to create a project in Visual Studio, how to add things to the project or to your Visual Studio solution file, what the heck a solution file even is, how you can add source files to your project, how to compile things, how to run things, how to debug your program, all that kind of stuff for this first part of the series. And then for the next part of the series, we will not rehash anything that we talked about prior. Just going to assume you were there, and we're going to keep on trucking along with the rest of the agenda. All right. So for this one, if y'all have Visual Studio all ready to rock and roll, go ahead and open it up. And you might see some differences on my system and your system, all right? So don't hold that against me, all right? So this is Visual Studio on our course VM, all right? I just decided not to give out a VM because this thing is massive. So no point in downloading like a 30 gig VM, probably a little bit easier just to download the program. All right, so once you have Visual Studio up and running, you want to create a new project. So on the right-hand side, you should see Get Started. All right, so create a new project. Now you just wait a little bit here. And I'll try not to go at the speed of light. I'll try to keep things at a slower pace because I do know we have 90 folks in the Zoom session right now, which is amazing. All right, so creating a new project. What in the world can we do here? Well, we can create something called an empty project, or you could create something like a console application. All right, so if you wanted to, you could go ahead and click on console app and just hit next. And it wants to know, hey, where in the world do you want to save this project? There's a default folder that'll be like source repos. You can drop this wherever you want. Doesn't matter. I'm just going to go ahead and keep it the same here as repos. And I'm just going to say name of the project is Hello C. And hit create. And it's going to go and do its thing. Might take a minute. Cool. So this is a basic solution file for your project that you just made called Hello C. And you might be looking at the name of the file right here on line number 1, and notice the extension .cpp. All right, that's C++. This isn't an introduction into C++. This is an introduction to C. So one of the first things that we're going to have to do is come over to the far right-hand side on your Solution Explorer window. There are a couple of folders under here, and if you expand source files, you should see your helloc.cpp file. What I'd like for you to do is go ahead and right-click on that, go all the way towards the bottom to rename. And what I like to do is I like to change the name of the file to just main, and just delete the .cpp and just make it C, right? And then hit enter to make that take. And then it's going to go about, do its thing, and you might see a little red squiggly over here for standard C out because that's specific to C++. So go ahead and go to that line and delete that line entirely. Okay, and also for the include, just get rid of that as well. And these comments here. These comments, all right? This is a nice little way to help introduce you to Visual Studio, right? So it says, hey, if you want to run your program whenever you think it's ready, you can do so by hitting Control F5 or coming up to the debug menu at the top. It says debug, and you can start debugging or start without debugging, right? So we're going to play around with debugging a little bit later today. And then some tips for getting started with Visual Studio. Tells you a little bit about the windows that you might see. All right, so you can go ahead and just get rid of all those comments. And,
hey, Jonathan, I'm going to pop in and answer a question really quick here. We have a question.
Yeah, go for it.
The Zoom chat. Can you explain the main uses or advantages of C versus C++? This is an excellent question. It is an extensive question, and we could talk about this for the rest of the 2 hours, but C++ is a object-oriented, a superset, if you will, of C. In other words, it shares a lot of the same syntax, not all, but a lot of it, but it is a functionally a different language than C is, even though they look very similar. The object-orientedness is the main key feature to talk about. But really C++ and C both originated in a general similar period of time and have expanded for their own uses. So you're going to see C a lot more, the programming language, in lower level operating system components, and you're going to see C++ in those components, but also in other things like video games and desktop applications. Very expansive. So both of them have very different uses, and obviously we're covering just C today, but feel free to explore.
Yeah, that's a great question and an awesome response. Thank you, Jason. So why did I choose C instead of C++ for an introduction for programming? C++, there are so many different versions of C++, same with C as well, right? But I do think that it might be easier, if you will, to learn pure C first, right? That's just my personal opinion. Jason, agree, disagree. But yeah, so I know a number of folks in my industry do nothing but pure C for implant development. Right? There's also some folks that are converting over to C++. I'm slowly becoming one of those folks. And maybe towards the end of this entire series, I'll talk about some of the advantages that C++ can bring specifically for implant development for Windows. All right, so with all that being said, let's come back into Visual Studio here. And I want to talk about just a couple of things here. Up here, you see debug, right? So it's on debug, and if you click on that, you have release, right? Debug and release. Those two different modes basically can kind of dictate how the program is built and what's inside of that built program. For testing purposes and stuff like that on your local system, a debug build is totally fine. If you're sending something out to a production environment, or you go ahead and build your implant and you don't want the debug version of your implant to go onto a target, because it's just going to be ripe with information and the size will be a little bit large. Release mode. All right, if you were to click on that and choose release mode, this is, no kidding, the mode that you want to release the finalized version of your program or of your implant. And then next to that, we have an architecture, your platform, x86 for 32 bits, x64 for 64-bit. All right. So go ahead and switch that over to 64 bits. Hopefully you are running a 64-bit system. And then we can go back to debug. All right. So this is our basic skeleton, if you will, for a traditional C program, but it's missing some things. All right. So I want you to hand jam some stuff in here. I'm not a huge fan of just giving you a source code and say, hey, cool, copy and paste things, and we'll learn along that way. I want you to have as much time on keyboard as possible. So let's hand jam some things together to go ahead and get started with this. All right, one of the first things I want you to add is a header file. I'll get into these header files in a second. All right, so we have a preprocessor directive, and we use the octothor or the hashtag or the pound, whatever you want to call it, and we give it a keyword called include. And Visual Studio is nice enough and intelligent enough to kind of say, hey, I think I know what you're about to type here. So you can go ahead and tab that out. And I'm going to include the name of a header file inside of a less than and greater than symbol. The name of this header file is going to be windows.h. All right, so I got that one in there. I want you to add in another include. And I want this one, I want you to type in stdio, and it should autocomplete here, stdio.h. Right, and then I will explain all of this in great detail, but let's go ahead and get this all typed up here. Let's see, am I missing anything? And apologies in advance, I'm going to try to occasionally look back at the Zoom chat to make sure I'm not missing anything. Jason's going to help out too, because I do know we have 97 folks in here now.
Got my eyes both on the webinar chat and the question and answer, guys. So wherever you decide to ask questions, we're here.
Awesome. Let's see. We got a couple questions in there. Are header files the same as a library import, like in Python? Very similar indeed, right? So if you think of a Python import, a module, Python module or Python library, there are functions inside of that module that you want to bring into your current namespace or your current program. All right, very similar thing happening here, where saying, hey, windows.h, everything inside that header file, because it has other includes as well, I want to bring in everything inside there into this program because we're going to depend upon it. Stuff like standard IO, basically standard input output kind of things. That way you can call a function like printf if you want to send something to the terminal. Let's see, is x86 64 option an abstraction for something at a lower level? Abstraction. Let me see if I understand your question fully here. An abstraction for lower level. If you're talking about the lower level, meaning assembly, 32-bit assembly versus 64-bit assembly, that low level, is that kind of what you're talking about, that abstraction? Okay, yes, if you're thinking that low level, right? So the assembly, the opcodes, behind this compiled program, yes, you would see a difference at the assembly level for a 32-bit compiled program and a 64-bit compiled program, right? The big thing will be the registers that are being used, the size of addresses, the size of the operands, the size of the stack addresses and values on the stack, so on and so forth. But yes, so that would be a big notable difference between 32-bit and 64-bit. Cool. All right. Hopefully we're all cut up there with the Q&A. Awesome. Now inside of your main function here, right, you see int main and some parentheses, and you see what I like to call the curly brace, right? So that's a curly brace. I want you to type in a couple things for me. Just say int and best class, and do a comma, or sorry, a semicolon, semicolon. Unsigned int next class, and equal 770. And we'll do an unsigned long third class equals, and this one 0x870. All right, so a hexadecimal value of 870. Cool. Now, go ahead and come down a few lines and type out printf, and then give it some parentheses after the printf. Printf is brought to you by Standard.io header file and allows you to send a message or display a message to the terminal window, which is basically standard out. All right, so inside of the parentheses for printf, put in two double quotes and say, welcome to the workshop. And at the very, very end, we do a \n, which is going to be interpreted as a new line, right? That way, when this thing actually is printed out to the terminal window, the prompt should be down on a new line. And then at the very end, just add a return statement and say return 0, right? So we are effectively returning a value back to whoever called this function. All right, so I will leave this up here for just a moment so you all can type this in and hand jam this.
While we're doing that, Jonathan, or while everybody's hand jamming, we have a question here that I think warrants sort of both of us to answer, but it's a great question. The question is, if I know that my software needs less than 3 gigabytes of RAM, is it not better to compile it for 32-bit? And will this be compatible for all systems? So when we're talking about 32 and 64-bit programs, we're talking about programs that are, there are a lot of ways to answer this question. And it's going to be a little bit subjective based on exactly what you're targeting, but we are talking about the architecture of an operating system first and foremost. And if I'm correct, 32-bit Windows operating systems in any modern Windows operating system don't really exist anymore. And they it's a legacy sort of format that changes maybe with other operating systems, but Windows is primarily 64-bit operating system. It's modern formats like Windows 10 and 11, and that's what you're going to see the majority of the time that you're looking at a Windows operating system. In my own experience, you would only compile something as 32-bit if you were trying to keep it, if you were expecting to use a 32-bit operating system for legacy purposes. But also just sort of philosophically, even if you are developing a piece of software, outside of the architecture question, I would always develop software with the intent that it could be used in something bigger along the way. In other words, if somebody else wanted to take your code and maybe fork it and make incorporate it into something larger, you think that the piece of code you're writing could be used in something that's 10 lines or 100 lines or 1,000,000 lines. And you sort of plan that as you move forward with whatever you're building of any size. Jonathan, what are your thoughts?
Yes. To add to that, I would say that from the implant development world specifically, right? So that's my perspective here, is if you're, let's say, process injection, right? So I'm not going to dive too deep in the weeds of process injection. However, let's just say that there is a process you want to inject code into. That is a 32-bit process. Believe it or not, there are plenty of 32-bit processes that run on 64-bit systems. If that is a process of interest to you, your implant, your code needs to speak 32-bit or x86. All right, there's an underlying mechanism for Windows that allows that to happen, allows an emulation to happen for a 32-bit code to run on a 64-bit system, all right? And that underlying system is called WOW 64, Windows 32-bit on Windows 64-bit, all right? So that's a little perspective from the implant world. I see another question out there about if your program is not returning a value, why not just use void main? Yes, you could. You could do void main, all right? But specifically, I am returning 0. I was going to talk about this in a little bit, but I am using 0 to say an indication of success, that the program ran successfully without error or what have you. So whoever called main or whoever called this might want to know if there was success or failure. All right, but yes, you can use voids, and we'll talk to that here in a little bit too. Awesome. All right, so I think we're caught up there. Those questions. All right, so everybody should be on the same page now. If you haven't saved it, go ahead and save it. And what I want you to do is up in the top, go ahead and click on local Windows Debugger. Right, so it's going to go forward and start to compile everything down and build it, do its linking, all that jazz. And you might get a little warning that says, no, that went away so quick here. Basically, a little warning that says a variable is not actually being used. Right, that's fine. We don't care right now. So Visual Studio will fire up another window, a little console window, and your message of welcome to the workshop or whatever message you want to use should have been displayed to the terminal. All right, and it says, hey, this has exited with code 0, and G, what do you know? That's what I told you to exit with because it was successful. Right, and you can go ahead and say, hit a space bar or hit anything to go ahead and close that window. Cool. You just made your first C program, but it wasn't really specific to Windows at all. And you might be thinking, what are we talking about? We just ran this on a Windows system, so why not? Okay, so for those in the room that might already be a little bit familiar with Windows programming, you might already know what I'm talking about. But my assumption is that you have never done anything in C before in your life. All right, so what can we do to make this specific to the Windows platform? Windows wanted to be just a little bit different than other platforms, right? So what they were doing to make this different is they kind of created their own data types that are defined in these header files. All right, and some of these data types, and let's see if I can fire up the website for it. See if I can pull up the website for all the data types for Windows. All right, give me just a second. See if I can drag this tab over. And zoom in. All right, Windows data types. There are a ton of Windows data types. And you might see something common, a little trend here. every Windows data type is all caps. All right, stuff specific to C or to C runtime, if you will, lowercase, as we just see for this program. Right, we have bytes, callbacks, chars, double words with numbers at the end of them, so on and so forth. A massive, massive list. I'll go ahead and copy and paste this link in the Zoom chat. All right, so Windows data types, for those that want to pull that up on your own system. But what we can do here for this program is we're going to convert these data types to Windows data types. All right, I'm going to start with the very, very first one right here, this int. We're going to convert these things to all caps. All right, so that's how Windows does an int. Okay, and so we have int main and empty parentheses. For me, just my preference, my opinion here, anytime you have a function that does not accept any arguments or will not accept any arguments, I like to be more explicit about that, and I'll type in void. That way, anybody coming after me, looking at this and say, hey, do you really have an opinion or a stance if this function is going to have arguments or not? And so I say no, so void, right? So just saying, yes, I am going to have a stance or an opinion if main is going to have any function parameters or arguments being passed to it. So void, nothing, into the void. And we'll change that to uppercase int. Now, this is where things get a little bit interesting. All right, so we have unsigned int. All right, so on the Windows side, if I double click and grab both of those, an unsigned int for the Windows data type is uint. All right, so just uint, right, an unsigned int. And if you follow that same kind of methodology or naming convention, if you will, you can say u for unsigned, long. Cool.
Hey, John.
One small, yeah, go ahead.
Real quick, we have a few questions, but I really want to get to one of them specifically that goes along with this situation. So somebody asked that the link you put says Win32, and they said, don't we want Win64? And let me tell you, I'm very happy you asked, because this is a little naming convention that Windows does that I'd like to introduce right now. Win32 is a term that generally refers to the Windows operating system's API, or the core of the API that we're going to be demonstrating for most of the course. There is a large discussion about how Windows subsystems work and exactly what the Win32 term might refer to. That is wholly outside of the scope of what we're talking about today. But just for future reference, if you see Win32, that refers to the Windows API and not to a 32-bit version of the API specifically. But great question. We have some other questions we'll get to in a bit.
Cool. Awesome. Thanks, Jason. Sweet. All right. So while Jason was answering that question, at the very end of the program for the return statement, I typed in error success. All right. So Windows programs, you can indicate errors in quite the number of ways. That way, whoever is calling your function or looking at your program as it runs or as it exits or terminates to indicate, hey, did you fail? If you failed, why? Specifically, why did you fail? And it's kind of an opposite here at the same time. Error success, right? Sometimes Windows isn't so good with their naming conventions, but other times they are great. All right, so if you come in here and just type in error underscore, and I hit control space bar will bring up the IntelliSense prompt again. You can just go through and casually look at all of the different error codes that Windows has already defined for you to use for your functions and for your programs. All right, there are quite a few of them. So we're just going to say, come back to the error success here. And I'll go ahead and save that. If you wanted to, you go ahead and build that again. Nothing should really change. All right, should go ahead and run all fine and print off the message again. Okay, cool. And what I want you to do to get to know Visual Studio a little bit more, hit F12. So click on your ulong, click on that, and hit F12. All right, so F12 will bring up the header file where a particular data type has been defined or where a function has been declared or has been prototyped. Okay, so you can see it's using this keyword called type def, and we're saying unsigned int 64. All right, so this is basically telling you the size that this variable will be when it executes. All right, int 64, 64-bit integer. And if you go to the uint, or the unsigned int, and if you hit F12, you go to a new header file called the minwindef.h, and you see a type def here for unsigned int. And maybe a question pops into your mind about, well, if everything is just type def around those other like C runtime data types, if you will, why use Windows data types? And that would be a great question. And I would say if the underlying data type were to ever change, right? Sometimes Windows can do some shenanigans behind the scenes when they release updates or what have you. If the underlying data type ever changed and you were not using uint, you would have to go through your entire solution or your entire project everywhere that you used uint and update it to whatever the new thing is, right? Should it be a big problem these days? It was a big issue from 16-bit, went to 32-bit, and so on and so forth. But my opinion is if you're dealing with Windows programs, just use the Windows data type to keep things nice and easy and backwards compatible, just in case anything changes on the back end. All right, let me see if I'm missing any questions here.
We've got one pretty complex one. Not sure if you want to tackle it now.
Oh, regarding Ivan's questions. Libraries. Okay, let's tackle that one towards the end. I want to move us a little bit.
It's a great question, by the way.
Yeah.
But just to the individual who asked it, it's a great question. The scope of it is, but it belongs somewhere in this series. We'll get to it towards the end, just so that we can make sure that we have the audience captured with a little bit more data before we get to it. It's pretty high level.
Yep. Absolutely. Yeah, keep these questions coming, and then we'll tackle them around the right portion of the workshop as we see fit, tied to what we're kind of talking about at the moment. All right, so now you have this program, I want to explain a few more things for you. Over here for the int main void thing, all right, this line is basically saying I am creating a function called main. And it has a very specific return type because I want to return a value to whoever is calling this function. And that particular value or that type is going to be an integer. And main, right? You might be wondering, do I have to call it main? Yes, you do. However, there are caveats to this where you can define your own entry point and name it whatever you want. It does not matter, right? But because what we are doing is we are linking with the C runtime, right? It has to be called main, right? This is the default entry point for our program because believe it or not, there's actually another function called C runtime main that calls this main to go ahead and kick everything off. All right,
and,
so
just to extend onto this. If you're having any trouble understanding the concept of these types that we're using, or you're new to C, you can think of int and error success, and what Jonathan has right up there as opposites of one another. The program is going to take int and void. it's going to take in a void, or nothing in this case, and it's going to return an integer.
Yep. Spot on. All right, so what we have here is just the function header, if you will. And then inside of the curly braces, or these squigglies, if you will, would be the actual body of the function. All right, what is the purpose of this function? What's it doing? What functionalities does it have? That's all of this stuff right here. Specifically, each line that we see here is a statement. A statement will always end with a semicolon, and just my preference alone, I don't like to make very complicated statements. I don't like to have too many things on a line. There are some folks that like to add in more variables, say something equals some value, right? I hate that. I think that can be confusing to whoever is coming along after you, looking at your source code. Break things out, right? Like this on its own line. That's just me. Y'all can do whatever you want. All right, so these are all statements, every single one of these ending in a semicolon. And if you miss a semicolon, Visual Studio will get mad at you, and it will let you know what's going on. So taking a look at the first variable here. You have a variable of a particular type. This type is integer, saying, hey, the data that gets stored in this variable, I want you to treat it as an integer, not as like a string or a pointer, like a memory address to something or anything like that, right? So we're going to treat this as a number, or as an integer. And it's not initialized, meaning we're not giving it a value right away. And I did this for a reason, because I want you to, wherever you have this line, I want you to get your mouse cursor further over to the left and click in this little column right here, right? So if you look at the little purple plus signs and stuff, this is where you can set breakpoints, right? So you can set a breakpoint on any line that you want. But for now, just go ahead and set one on wherever you have this integer, this variable being defined. You can also right click and do the same thing, coming down to breakpoint. Cool. So what I want for you to do now is we're going to debug our program. You're going to debug your own program. So go up to the top again and say local Windows debugger. All right, so we're going to debug this application here. Opens up the console window, and we should have a paused state. And let all the windows come up. All right. Your debugger view might look a lot different than mine, and that's totally fine. At a minimum, you should have your source code that should still stay. Down towards the bottom is a little tab where you can have autos that are being watched, the local variables for your program, and a watch. A watch is kind of cool, where you can enter the name of a variable, and it will watch that variable for the program's lifetime. Over towards the bottom right might be another subset of tabs. So for this one, for me, just the setup, it's giving me a memory layout for the program, registers, the call stack, so you can see what functions have been called and who called them, breakpoints, so on and so forth. I'm just going to leave that as the registers.
We've got a question about what are breakpoints, by the way. Probably good to answer that.
Yeah, sorry. A breakpoint, that's a great question. Whenever you want your program to pause, you create something called a breakpoint. Right? We are going to pause execution, or we're going to break execution for the program and say, hey, I want you to go ahead and break on this line or on this function or what have you, because maybe there's something specific I want to view. There's some kind of issue that's happening, and you are going through trying to debug the issue. And so I'm going to break on that line or break on that function call to see what's going on. At the assembly level, what's happening is Oh, cool. It gave us source code too. We are setting a breakpoint on the actual instruction that is going to be executed next. All right. And so that's where it says, hey, we have this move. Right? I'm not trying to turn this into an assembly class. That could be a whole workshop series in and of itself. But basically, this is an instruction that is the equivalent of this line of C. All right. So that's where we're pausing execution.
Sorry, if you're if you're thinking about when will I use this, or if this is a lot, you can try to think of breakpoints as stopping time for your program and being able to look at the state of every single variable and memory and whatever is going on in the program at that point in time. If that's still confusing, what I'd implore you to do is just start using some breakpoints, put them somewhere, and just start looking at whatever you want. And I think over time, as you use breakpoints, it'll become clear why you will use them. They're very self-explanatory in that way. If you just keep using them, you'll be able to see all the cool functionality that they give you as you debug your program throughout its lifetime.
Yep, spot on. So hopefully that answers your question there. So here we are. We have paused execution. We hit our breakpoint, and you can see down in the locals window the three variables that we have: best class, next, and third class, and with some values with them. Now notice that these values are really not the values that we have given them. So that's very interesting. So hex 870 for third class, but third class has hex 3A. All right. The reason why, take a take a little assumption that somebody might be wondering why that is. I don't want to dive deep into function frames and stack frames, but basically what's happening is up until this point, these variables like next class and third class, because they haven't been executed yet, they have not been initialized and set to the value yet. So there could be, for like this instance right here, some garbage that was left over from a previous program that ran, or a previous function frame on the stack that's just laying out there in stack, and we just so happen to pick up that garbage, and now it's inside of our variable. Right? So garbage data is something to be cautious about, and a best practice is to always initialize your variables as quickly as possible. All right, if you don't have the registers tab, don't worry, that's not a critical item for what I'm trying to show at this point. All right, so we paused here, right, on next class. Let's go ahead and allow the program to execute that instruction, right? So a couple of ways to do that. Towards the top in the file menu, you have a little arrow that's like curved, and there's a little dot down underneath that, and to me, that's your breakpoint. And so we're saying, hey, let's go ahead and step over this, or you could hit F10 and step over and just execute that instruction or execute that line. So I'm going to say F10, and down towards the bottom, highlighted in red, just to say, hey, something has changed here. We have hex 302. If you wanted to change the values for how they're being displayed, you can right-click on any one of these and check hexadecimal display, or uncheck that, and it'll show you the decimal value. All right, I'm going to flip that back to hex. Okay, so I'm going to go ahead and hit F10 again, and now we see third class has been initialized to the value of 870. Now, there's another step that you could do. There's step into. Step into is very useful if you want to go inside of a function that is going to be called, like printf. If you wanted to reverse the internals of printf, how in the world it works, you can step into that and do that, but we don't care about it. So we're going to step over the function call because I don't want to go into the function call. So F10 to step over. And if you want, you could go back to your console window, and it should display the status message for you. Welcome to the workshop, or whatever string you gave there. And to execute this once more, F10, return error success, and F10, and we are done. All right, so that's a very, very, very high-level introduction into debugging your programs locally using Visual Studio. It's a very robust application. We're only scratching the surface of a lot of the features here, but debugging is one amazing, amazing feature of this. All right, how are we doing on questions? I think we're doing pretty good, huh?
I've covered a few of them just by typing.
Okay, all right, awesome. All right, so let's go ahead and talk about this printf statement real quick. Printf, as you saw, can display a message to a terminal window, but it can do so much more than that. There can be something called a format string that gets passed into printf. All right, and that's what this is. This is just basically a string that's getting passed to this function printf and displays that for us. Now, to make this into a true formatted string, we can pass in these types, or these placeholders for types that we want to be displayed to standard out or to the terminal window. I did not have the website handy for this, so let me open up my other window here. All right, so printf. Here is how you can specify the type or the value that you want to be displayed inside your message. All right, the type here, this is the type of data that you want printf to be displaying for your program. All right, you have decimal values that are signed. Treat them as a signed value. And you say %d or %i. Right, so the standard is, hey, if you have a % symbol inside of your string, I need a type after that, right? So you can have a signed decimal value, octal, unsigned, right? For anything that's unsigned, it'd be %u. And if you want something to be displayed as a hexadecimal value, you could do %x, and if that's actually uppercase, it will show you the capital case or capital values of those hex characters. All right, so you could do HH, right? So that's another type for the chars, uchars. There's ints, right? Short int, short unsigned int, so on and so forth. To get the idea. Okay, so let's go back to that program and let's modify your format string, your printf statement. All right, we're going to add a couple more here. What I like to do is just say printf, and inside of that, your double quotes, and then a new line. All right, this is basically my little standard printf statement, and we're going to add a couple here. So I'll return and return. All right, and now here is where you can actually specify the message that you want to have in here. So you could say, I want to print out the best class. And because that's an integer, it's signed. So use %d. And then you use a comma after the double quote and the name of the variable, best class. IntelliSense should pop open and say, oh, is this a variable it's looking for? Yes, it is. And so the next class, we can print that value out too, or display that value. Now, because that's unsigned, %u for unsigned. Next class. And of course, you know what's coming next. LL for long, and the U is because it's unsigned. Third class. All right, at this point, go ahead and save it. Now I'll give you a little bit before I go ahead and try to run it and build it. Okay, cool. All right, so if there are build errors, just hit no. All right, and it says we have an uninitialized local variable being used. All right, so thank you, Visual Studio, for catching that for us. And it's saying, hey, we don't want you to utilize a variable that hasn't been initialized with a value because it has garbage. So you might have some undefined behavior for what in the world might happen for whatever is inside of best class. So let's go up here and let's change that. And of course, the best class is 670. All right, so make that change and build that. All right, and then breakpoint still there. Breakpoint has been hit. Cool, if you want to, you can hit F10, step over this a few times, and you can see everything changing down below, and hit F10 a couple more times, and then we'll stop here on the return statement. Open up the console window, and you can see the new status messages or strings that are being displayed to the console window. If you're done with everything, you can just hit F5. Go ahead and finish running the program throughout its entirety. Let it exit and terminate. All right, and then hit space for the other window, and it'll go ahead and close that window.
Hey, Jonathan, we have a question. If your notes.h is going to be made available to the audience at any point.
Oh, notes.h is basically just a copy paste from Windows about format strings and printf. But yeah, that's all that is. Nothing special. Nothing unique to me.
I will hunt down that format specifier page in Windows, and I'll pop it in the SANS Offensive Operations Discord and our webinar chat for everybody if you'd like to see.
Cool, awesome. All right, so next thing I want to talk about is some of the things that you can do with these numbers. All right, some of these variables that you have, it's useful at some point in time maybe to do some math on it. All right, this might be going back to old school days of your order of precedence or order of operation, your PEMDAS and stuff like that. Please, my dear Aunt Sally. Hopefully some of y'all remember that. But what we can do here is, let me get rid of that, is let's see, what's one of the best ways to actually show this? Right, so inside you can say, hey, the name of a variable and the name of another variable, you can add those two together. Now for this particular instance, we are adding together two different data types, an int and an unsigned int. I was kind of hoping to avoid getting down to the bit level of the actual binary bits behind a variable. I was kind of hoping, I would love to dive into that for the next workshop because we can really spend some serious time there. But just for now, a teaser for next time. I would strongly discourage you from mixing and matching different data types, doing math operations like signed, unsigned, whether it be subtraction, addition, division, whatever the case. All right, so the reason behind that, there are a couple of real world examples of what might happen if you do that. All right, so for one example, YouTube. All right, so YouTube, Gangnam Style. That was a crazy, wildly popular video, right? and it broke YouTube, right? The number of views basically was being held in a 32-bit variable. So that means there are only 32 bits that could be used to represent a number. There's a max number for 32-bit ints, right? So let me come up here and show you that. So int underscore max, I'll just leave that there so I can type that out. That number, that huge number, is the maximum value that a signed 32-bit integer can hold. So YouTube broke that. YouTube broke that, and what happened was, hey, we only have 32 bits to represent a number. You can't shove more bits into that. And so it started to show a negative value for the number of views for that particular video. Right? So the fix for that was YouTube had to then use a 64-bit integer to say, hey, you know what? Let's use 64 bits to represent the number of views for a video. All right. So yeah, one real world example using YouTube there for for mixing and matching and stuff. All right. So yeah, you can add. All right. You can add a couple variables. One thing that's kind of cool is you can add and update at the same time. All right. So to do that, you say plus equals. All right. So best class plus equals the next class. You can do this for any number of other operations as well. So for example, I'm just going to type in some nonsense here. You can divide and update the assignment. So you can do that. You can multiply and assign all in one shot as well. All right, there's a number of operations that you can do. And then you can also, if you want to just increment a variable by 1, you just give it the variable and you do a plus plus. All right, just saying, hey, increment whatever is inside the best class variable by 1 and only 1. All right, we don't need to dive down into how in the world you do arithmetic operations. All right, I'm pretty sure we're all really familiar with math, what division is, subtraction, all that type of stuff, right? The one thing that's kind of cool for those who've never done C before is the whole plus equals kind of thing. All right, being able to do some kind of mathematical operation and then assign it to that variable all in one shot. All right. Another thing that you can do with these variables is you can shift some bits. All right, what in the world do I mean by that? If you do 2 greater than signs, that means we're going to have a shifting operation, a shifting of bits to the right. And you can specify any number here, and I'll just say 1. All right, so best class, shift right by 1, okay? And then what you can do if you want to see the result of that, let me go ahead and get rid of this one, is you can wrap this up in a printf statement. So printf, all right, so I have the best class greater than 1, but however, don't try to print that, all right? We're not going to do that. We're going to go ahead and give it a format string, and we're just going to say best class shifted right 1, and then the %d, because I want to display that as a signed decimal. And I'm going to get rid of that breakpoint. I'm going to move that breakpoint down to that printf statement. Save it and run it. Then we wait. And we crash. Nice. All right. That's cool. Come on, Visual Studio.
While we're getting everything back up, I'll leave it to anybody in chat to maybe guess what's going to happen in that bit shift operation.
Oh, come on, Visual Studio. Everything was going along so well up to that point. All right, I'm going to let Visual Studio finish doing its thing to get ready here. All right, cool. Sweet, ready. And let's try this again. Local Windows debugger. All right, stay with me in Visual Studio. Sweet. All right, so we pause right here for the printf statement, best class, shifting to the right by 1, okay? So go ahead and hit F10, all right, because you know best class, you know what value best class is, right? 670. It's also been printed out already. So step over that. All right, and come back to your window. 335. Interesting, 335. All right, so if you were to try and convert that number into binary, what's happening behind the scenes would be all of the bits that are there that represent the value 670 have been shifted to the right by 1 space. And let me try and show you what that looks like. I'm just going to copy and paste this in here. Make a comment. All right, so this is the binary representation of 670, okay? What we just did, let me make another comment here, is everywhere you see a bit being set to the value of 1, right? So bits can either be set or clear, right? Set means it has a value of 1 there. I'm going to manually do this. All right, so we got 4, and because we're shifting it to the right, this 1 moves over there. All right, and that moves over there, 1, 1, 1, maybe. That might look right. All right, so that's basically what's happening. I hate doing math in public, but yeah, shifting by 1. That's all you're doing is moving all those bits to the right by 1 space, or one bit, if you will. All right, same thing would happen the opposite if you would shift left. All right, shift left by 1 or by 2. Right, that's all that's really happening is you're just shifting of bits one way or another. All right. There are a few other operations that we can do talking about bits. All right, so that's the binary representation of 770. All right, so if you want to try and type that out, feel free to go and type that out. Some of the other operations that you can do here is you could do a bitwise operator. Sometimes these are very, very useful to do, and they are or. I'm just going to keep this here in comment land. You have or and XOR. All right, let me format this a little bit nicer here. All right, so or the OR operation will look at the two bits being compared and will either set or clear a value, right? So either or. If either or is like truth tables, all right? So if either or is set, then the resulting value will also be set or be true. So either or is all 0, 0, 0, and so either or here. So 1 or 1, 1 or 1 is 1, 1 or 0, at least one of them is set, so the result is going to be set 0, 0, 1, 1, 1, 1, 0. All right, so how do you do that in C? Is something like this. Best way to do some things is to just print it out. All right. So OR operation. If you print F and you say OR %D, you say best class or next class. I'm going to update my breakpoint to this one. Save it and run it under local debugger and with the breakpoint right there. I'm just doing this in a debugger just to get you more and more familiar with the debugger. The better you are at debugging programs, the better of a developer you'll be, in my opinion. All right, so F10, step right over that. No, I messed up on on my spacing here. All right, so this is the value here, 926, if you OR those together. Then you hit continue, F5, and program terminates. I'm going to go back into that printf statement and add the new line there. For and, all right, and at the bit level, when it's comparing two values, for the resulting operation to be true or to be set, both values that are being compared must also be set, all right? So comparing 770 and 670, we got that. Quad zeros, 0, 0, that one's set, nothing there. Okay, so that would be an AND operation. On the C side, right by the ocean, right? Similar kind of concept to the above printf statement. Trying to be a little bit more lazy using copy and paste. Sometimes it'll bite you.
You've ruined Seaside for me now. Every time I hear that for the rest of my developer career, you've ruined it.
No, I'm not sorry. Seaside. Okay, so this is how you do that on C. All right, so this is the C side of an AND. All right, and I'll wait to show that here. Let's do XOR. Let's talk about XOR real quick. XOR is an exclusive OR. All right. So instead of having either one being set, right, we have the exclusiveness, the exclusive OR. All right, so I'll give you a second to think about this in your mind, or in your head real quick before I go ahead and start typing out a bunch of zeros and ones here. All right, again, we are just looking at 770 and 670 right now. All right, for the exclusive OR. Okay, so exclusive OR, both values cannot be set. All right, if you want the resulting operation to be true or to be a 1. All right, so looking at the first set of 4, that's going to be quad zeros. All right, and in this next bunch, exclusive OR is 0, 1, 0. And then we got, that's a 1. going way too fast here. 1, 0, 0, 1, 1, 0, 1. Exclusive OR 1, 0, 1, and 1, 1, 0, 0. There we go. Printf it. All right, so the exclusive OR is the caret, I guess you call it. I don't know what the technical term is for that one, but I just say caret for exclusive ORs. All right, so you can go ahead and build your program again. Cool, we hit our breakpoint, and I'll step over those. Cool, this is interesting. I didn't see this the other million times we just ran through something. Printf actually returns a value. All right, printf saying, hey, we returned a value of hexadecimal 9. And you might be wondering, what is that? Why would printf return any kind of value to us? So right here, if you were to count this up, that should be the number of characters. Should be about nine characters. Of course, starting with 0, we count with 0. And we're saying, hey, this is the number of characters that we printed off to the terminal, right? Or to standard out. All right, so pretty cool gee whiz for you in case you ever do, Nerd Jeopardy. Excuse me, looks like I was missing a new line there. All right, cool. The and value is 514, and let's execute the X or Y. Cool. Come on, let's go. All right. Cool. So you kind of saw what happened when I made an edit to source code in the middle of a debugging session. All right. So what happened was I went up here to my best class printf, right? And I added a new line in here. I changed source right in the middle of a debugging session. And what Visual Studio had to do is to rebuild it, recompile it, and get me right back into another debugging session and reprint off all these statements here. All right, so the XOR of 670, 770 is 412. All right, go ahead and hit continue. All right, so you might be wondering, why in the world do I care about bitwise operators? What is a use case for this kind of thing? So I have an example here of a use case for AND. A lot of times in Windows, you'll see different flag values or different values that have been defined. All right, a lot of times you see a pound define, and you'll see some kind of value like flag 1, for example. You don't have to type this out, just kind of showing you. Let's say OX100. Okay, so hexadecimal 100. Behind the scenes, if you want to see if a certain flag is set to indicate like a permission or a privilege inside of a Windows token, or a permission for a process handle or a thread handle, right? There are these different permission values that have these constants, if you will, that look similar to like something like this: pound, define, name of a value, and the actual value itself. To test whether or not a certain permission is set, or if it's absent, you would have to find out where that bit is located and do it AND against it. So for example, let's go with the value 770. I want to shift it right by 8 times because I want to do a test to see if at the 8th bit, if it is set or if it is clear. So to test that out, I say and 1. Right, so that's kind of what your statement would look like, or the actual operation of it. And of course, a nice way to look at that on your window or the terminal window is to wrap that around the printf statement. All right, so printf. And let me get rid of that because I'm not actually using that pound define. And let's see, and 1. All right, so and 1, %d, and then a new line. Now I'm going to bring the breakpoint down to the most recent one. Run. Come on, don't go so slow on me. All right, give it a little space bar. Kick it in the pants a little bit. Cool, everything's looking good. And step over, F10. Oh, come on. And 1 is 1. All right, so that means that at the binary level, 770 at bit number 8 is set. All right, so if you wanted to, you can look over here for 770 and go to bit number 8. And what we did is we shifted that right 8 times to get the 1 all the way over here. And we just and 1. Say if it's set, cool. Go ahead and result true, if you will. And true is represented as a value of 1 or any non-zero. All right, does anybody have any questions about that stuff that we just talked about right there? Any questions? Because we're about to hit the lab and we'll end with this lab. All right, this will be a little bit of a challenge. All right, we'll see how y'all do. I got faith. All right, so this last lab will be until the end of the workshop, so about 40 minutes, right? Because I'm going to throw a decent amount of stuff at you. All right. Okay, so what I would like for you to do, I'll leave this up here for the entire time, and I can scroll down a little bit, is I want you to you can make a new program, you can delete everything that you've been doing thus far for the demo, following along with us, but I have a few to-do items for you. I want you to basically, from scratch, recreate your own main function for a program. Okay, so remember, a function has to have a few things. You have to give it a return type. It can be void, it can be an integer, so on and so forth. And then obviously a name and any parameters. Okay, so for this function I want you to make for main, don't give it any parameters, not necessary. And then your function body. Okay, so that's to-do number 1. That's probably the easiest part. All right, and also don't forget your includes, right, for your header files. Now, for to-do number 2, all this will happen inside of your function body, or main's function body. I want you to create 3 variables with very specific types, and also initialize those variables to these specific values. So for example, create an integer value, initialize that to hexadecimal 7F F. It's probably too many F's. And then create another one with a uint, value of 1. Create a double word. We didn't talk about double word, but a double word, if you F12 that, you will see how that is created. All right, and that's going to be the value of 1 shifted left 12 times. And I want you to print those out. Okay, print those out to your terminal window as a hex and a decimal value. Right, so looking at your format strings, all the different types, your format types for how they can be displayed to standard out. All right, hex and decimal for those 3 variables. All right, also to do number 3, inside of your main function body, I want you to experiment with adding your int variable with your uint variable, your unsigned int, okay? Something interesting will happen. I'm not going to give away exactly what it is, but I want you to experience that for yourself. And I want you to show that result as a hex, as a signed, and as unsigned. And then before you let that execute, I want you to pause or hit a breakpoint on that printf statement and kind of think ahead of what you think might happen. And think back to that little story I told about YouTube, right? When they only had 32 bits representing the number of views, right? Think what happened to that one. And then the last one, this one's gonna be a little bit more challenging because I want you to pick the proper data type, all right? We only talked about a few, right? So each one of these will fit in those nicely, all right? The first one is just hex dead beef, cafe babe. This integer value right here, all right? I can also paste these into the Zoom chat, because I know those are pretty large values. Okay, so at least give you a little bit of a copy paste, all right? Being a little bit of a nice guy there. I would just have a hand jam that. Okay, so those 2 do items, right? Go ahead, I kick it over to you all to go ahead and accomplish these items. If you have any questions, Jason's here, I'm here. Hit us up in Zoom chat or the QA section and let us know what you have, right? So when 4 o'clock hits, or maybe a little bit before 4 o'clock, we'll go ahead and reconvene and I'll demo just a couple of these items, right? And then we'll end the workshop for part 1, and that'll be a nice place for us to stop and get ready for part 2 sometime in July. All right, cool. Enjoy this section, everybody. And I will go ahead and scroll up a little bit more so you can see to do item number 2, 3, and 4. All right, so I know it's a lot of typing, but I think you learn best by typing as much as possible and hand jamming all these things. All right, enjoy. All right, popping in here for a brief moment. Want to do a little status check to see how everybody is doing with the lab here. We will come back about 15 minutes to the top of the hour. That way we can talk about some last minute items before we go ahead and officially end the workshop. I do believe there's still a couple pending questions that we need to discuss as well. Okay, if you are still working, feel free to continue working. I'm going to go ahead and go through this lab. So if you want to follow along, you follow along. I'm not going to verbally explain everything yet. I'm just going to type the stuff out. All right, so we're about quarter till top of the hour. One thing I want to show you right quick is about mixing and matching of different types. So this is just showing you how undefined behavior, if you will, of what could happen if you add an unsigned value with a signed value. All right, this is just one small item of your lab. So I have an integer called mix with the 7f. All right, if you hover over 7f, if you hover over mix, I'm already in debugging session. If you weren't in a debugging session and you hover over some of these values, it'll kind of show you the end result. So uint match just has value 1. We'll add match to mix, and then we'll go ahead and subtract 2 from that, and we'll print it out. Step over, F10, F10, all right? So mix right here at the very bottom is hex 800,000, 80 million, something like that, something crazy. All right. That's definitely more than what 32 bits can actually hold. All right. So if I go ahead and change that, it says it's actually a negative value. Whoa, what happened there? All right. So what happened is you have what's called like an integer overflow, meaning we overflow the number of bits that are being reserved for that value. So mix. All right. The 7F value is just basically one shy of the max that it can hold. And we go ahead and give it another to push it over and to flip it. And then it basically rolls over, falls flat on its face, becomes a negative value because that's what signed integers do. And say, this is all I can hold in my 32 bits, or sorry, my 31 bits to represent a positive number. You gave me another one, I have to go ahead and show this to you as a negative value. All right, we can dive further into that at the next workshop series. All right, so the next line 12 here, a match minus equal 2. Let's go ahead and execute that. Look at that. You might have thought, that should have given a negative result, right? Because we start off with 1 and you subtract 2 from it. It should be like 1 minus 1 is 0, minus 1 is negative 1. No, not the case, because this is being treated as an unsigned value. Unsigned values cannot display a negative number. And so what it does is it flips it and shows you a very, very, very large number. Okay, and then if you wanted to, F10 to print those out, and F5 to finish writing the program. And it says, hey, here's the hex value of that first overflow, and the result is this very large negative value. And if you treated it as unsigned, that's what the unsigned value would be. And then here we have hex all Fs, right? All Fs is how you can indicate a value of -1 if you were treating it as a signed number. If it's unsigned, then it becomes a very, 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 very large number. Okay, so please pay very close attention to your data types and how you are using said data types. All right, let me check the Q&A real quick. To-do number 3, let's go back to look at to-do number 3. Add an update. Yeah, so right here in the printf statements, I'm technically not adding and updating. However, the result is pretty much the same. So if you really wanted to, you could do the add and update here. I'm just trying to save a little bit of time and just throwing it inside the printf statement. I'm lazy sometimes. Let's see. Okay, so also back from this lab. This value here, I called this unsigned int IP because, believe it or not, you should be able to ping that address or that number. Look at that. That is the decimal representation of 127.0.0.1. All right, so in the next series, I'll kind of show you how you can create a function to take a dotted decimal IP address, convert it to an integer, or you can also convert it to a hex value, which is what the 7F is all about, right? So that's 127.0.0.1. Where this comes to play, a use case for this could possibly be in your implant. Instead of having the IP address like as a string inside of a variable, you could include that as a uint or as a ulong. All right, so kind of like a little tip and trick for today, if you will. All right, does anybody have any questions about that specifically? Okay, so Jason, why don't you jump on? And I know you've been itching to answer that one final question here.
That's a question. All right, so rewinding all the way back to that, and Jonathan, you know, I'm sure this is like the other architecture question, this is going to be multi-perspective, and that's what I'm going to put too. But all the way back to those architecture questions where you talk about 64 and 32 bits, What if software depends or uses libraries that are only available or maintained in 64-bit versions? Well, it's a pretty good time to jump back to that philosophy question we talked about, the philosophy issue in Ivan's question, with making sure that you are developing code that is going to be compatible as long-term as you can possibly think with other programs. Now, I actually would have to scroll down and find Ivan's question. If we were talking about a 32 or a 64-bit program to begin with, Jonathan, do you remember off the top of your head?
Ivan's question, the original?
Yeah, well, we're working with a 32 or a 64-bit piece of software in Ivan's question. I'm trying to find it here. So I'm trying to fuse the two questions together. I guess that Ivan's question says, would we need to compile something for 32-bit? So if software depends on a library that's in 64-bit, then we're going to need to, excuse me, if it depends on the use of a library that's in 64-bit, your 32-bit program, is that going to be able to maintain it? Does that sound like that's the right question? Yeah, I'm trying to fuse these two together to make sure I back on track. So 32-bit software is going to have trouble outside of emulation environments with 64-bit software, but there's some undefined behavior that we're talking about here at the same time. Yeah, Jonathan, you want to hop in here and maybe give some example cases? I'm trying to think some off the top of my head.
Yeah, so sometimes there could be some programs that are released or libraries released that are intended for 64-bit only, right? So, for example, if I'm working on a set of custom APIs that my workshop can use for implant development, and those are all focused on 64-bit, because I am compiling those down as 64-bit DLLs. That way they can go ahead and import, or statically or however they want, import that 64-bit functionality into their 64-bit program overall. So let's say I create a statically compiled 64-bit DLL that they want to use for whatever purposes that they need. I can also create a non-statically compiled 64-bit DLL that could be reflectively loaded into their implant, right? So reflective DLL injection, reflective loading is something that we talk about in 670 and also 770. If we get the green light to go ahead and release that, we're going to dive down into that a little bit further with you creating your own custom loader. All right, so that's where some of the finer nuances between 32-bit and 64-bit versions and libraries really can come into play. So hopefully that helps add a little bit something to that. Manuel, does that kind of answer your question if you're still around?
I think Manuel still is here. There's also the context of realizing that WoW 64 in itself, the emulation capability in Windows to translate between 32 and 64-bit processes on a 64-bit system. There is a lot that can be done, both in the context of implant development and just traditional Windows development, to interact with WoW 64. There are techniques that utilize it. And so the 32 64-bit barrier, while it is a component of a legacy version of Windows that is no longer in such frequent circulation, you're going to find that there's a lot of experimentation to be done in individual use cases to achieve specific outcomes.
Yep. Awesome. So Jason, if you have any tips or tricks that you'd like to share with everybody today, please feel free to do so. Does anybody have any questions for Jason or myself, webcast related, SANS related, about the courses or what's coming up next while Jason's getting set up here? Feel free to fire away.
Are you okay if this cuts off your screen while I share?
Yep, go for it. Destroy away.
All right. Is my screen visible?
Yep, gotcha.
Great. So this is going to be really short, simple, to the point, but something that you might play around with. And we're going to use a very contrived example for this. You can see I've got a function here. It returns a D word, and that function also takes a handle to a process. If you're not sure what a handle is, if you forget what a D word is, just roll with me on the vocabulary. This is a contrived example of something to try to teach a concept. So I'm going to call a Windows API function here called getProcessID. Processes each have unique identifiers that you can use, and getProcessID returns a D word. You can see by hovering it over there. And we're returning that D word right here. I've called it D word PID, process ID. Now, in a case like this, or other cases, it may be advantageous, and this is a decision to make for you as a developer, to make sure that whoever works with the D word PID that comes out of this function is extremely aware that it's not just a D word, it's not just a number, but it is a process ID. Now, again, contrived example, maybe it's very clear from this function, but in a very large program, you may have this D word exist among others, and you want to make it very clear to whoever's working with your source code that it's actually, we'll actually show you right here, a PID. Now, what did I just do right here? Go. Now the type name, there we go. I'm in Visual Studio Code, by the way, just in case this looks a little bit funky. But you can do all of this in Visual Studio just the same. So what we did is we defined a new type. And we're working with data types. But the beautiful thing about C is that you not only have the data types provided to you, but all the others that you'd wish to create. So in this case, I've actually created a D-word data type called PID. All this means is that in the context of the source code, not the program as it's executing, nothing other than what you see here on the screen, we are changing the D-word value, and we're adding a new one called PID. Or rather, we're changing the D word data type. And now you can see right here in the context of the function that it doesn't just return a D word, which you can figure out if you hover over it, but it returns a process ID. And you might say, that doesn't really change anything about the code. Why does it matter? And kind of touched upon it just a few sentences ago, but just to make sure we understand, this is very readable. It returns a process ID, but if you were hovering over this in a bigger program, you'd immediately see, okay, we're going to return a process ID. If later on in the program I have, an int main function that uses this, I might actually benefit a lot if I have lots of D words. And then there are lots of D words, and then I have a PID. I'll need to write it to a handle. We'll pretend it's there. That now we can clearly see in the context of a different function that's calling this one that there's a unique data type here that we're going to be working with. You could also achieve that over the name using the name, and this might not be recommendable depending on the group of developers that you work with or whether this is a preference. But the beautiful thing both about C and about Windows is, and Windows development in particular, is that as you're working with lots of different data types, you have the capability to write the code as it works for your particular circumstances. You will develop your own coding style if you move forward with C, and you may be asked either within the context of your team or by the requirements of a project or something you're looking to achieve to adjust that style as you see, as the requirements of the project or team demand it. So recognize the flexibility of that. But the thing I really want you to take away from this is that if you ever see a data type that you don't know of and somebody else has done this, that's how to figure it out. You don't have to take this up now. You don't have to take it up in a year, but you will see this done. You will see custom types that other people use in their C code. And so we've underscored lots of standard types here, but expect that some developers are going to have funky looking type names and that they're going to utilize this technique. if you're looking at source code in GitHub, you may not, depending on, I guess, if GitHub has this capability, I think it might be coming out with something similar. But if you're looking at source code just on a screen, you might not be able to do this, but in Visual Studio, you can hover right over it. Visual Studio Code, most IDEs hover right over it, and be aware that custom type definitions exist and they're at your disposal. That's all I got.
Awesome. Thanks, Jason. So yeah, that's a great way to end this part one of a 5-part series, hopefully a 5-part series of workshops. Introduction into data types specific to Windows, how you can F12 a data type and it'll open up the header file where it's been defined. And it's pretty nice that you can also create your own on the fly and just kind of rename them, even though at the base end, they're still the same kind of data type as a double word like unsigned long. All right, so thank you so much, everybody, for joining part one of our introduction to C, for Windows. As each part in the series moves along, I'll get closer and closer to more Windows things, talking about the Windows APIs, what they are, how to use them, data types that they return. And then towards the very, 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 very end, we'll be very close to using C for offensive purposes like implant development, so on and so forth, which will be a great landing point for y'all to be at if you're interested in taking Security 670. Jason and I are going to be working on a quiz of sorts for y'all to take to kind of gauge your current skill set to see if you are ready to take on Security 670, some of the things that will be coming your way in a 5-day course. All right, so part two will be in July. What are we going to cover real quick? We're going to cover strings, arrays, and if we can get to it, pointers and structures, structures that have structures within them and pointers to pointers. All right, so that's going to be a pretty big one. Might have to split that out into a couple, and then we'll be introducing Windows APIs as well when we talk about input and output stuff. All right, so does anybody have any questions? We'll hang around for just a couple more minutes for any parting shots. If not, thank you all for attending and have a great rest of your day.